So I've decided to create this algebra review video because most of you are going back to school in about a week or two. So let's review some basic concepts that you'll need in a typical algebra course. First, you need to understand how to add, subtract, multiply, and divide fractions. So let's briefly review that concept. Let's say if we want to add 3 over 4 plus 2 over 5. How can we do so? Now, whenever you're adding or subtracting fractions, you need to have the same denominator, which we don't have. For the first fraction, the denominator is 4. For the second one, we have a 5 in the bottom. So we need to adjust these two fractions. In order to get a common denominator, we need to multiply the first fraction by 5 over 5. Whatever you do to the top, you must do to the bottom. So if you're going to multiply the top number by 5, you have to multiply the bottom number by 5. Now the second fraction, I want to multiply the top and the bottom number by 4, because 5 times 4 will give us 20, and that will lead to the same denominator. So now we could add the two fractions. 15 plus 8 is 23. So the answer is 23 over 20. Now here's another example. 5 over 6 minus 4 over 7. Feel free to try this problem if you want to. Go ahead and pause the video. Now, if you're not sure what to multiply by the other denominator. So 5 over 6, you can multiply the top and bottom by 7. And 4 over 7, multiply the top and the bottom by 6. This will give you a common denominator of 42. Now 7 times 5 is 35. 4 times 6 is 24, and 7 times 6 is 42. And now we can subtract the two numbers on top. So 35 minus 24, that's 11. So the answer is 11 divided by 42. Now what about multiplying two fractions? What's 7 over 5 times 4 over 3? When multiplying two fractions, you don't need to have the same denominator in the case of when you're adding or subtracting fractions. All you need to do is just multiply across. 7 times 4 is 28. So you got to multiply the two numbers on top, and then after that, multiply the two numbers on the bottom. 5 times 3 is 15. So the answer is 28 divided by 15. So here's another example. 3 over 5 times 6 over 4. 3 times 6 is 18. 5 times 4 is 20. Now sometimes you may need to reduce the fraction, which is what we need to do in this example. 18 is 9 times 2. 20 is 10 times 2. So notice that we could cancel a 2. So the final answer is 9 over 10. So when multiplying two fractions, you could simply multiply across. Now sometimes you may have to multiply two fractions that contain very large numbers. For example, 28 over 63 times 56 divided by 35. Now you don't want to multiply 28 by 56 because it's going to give you a big number, and then you have to simplify that big number, which is a lot of extra work. The best thing to do is to simplify the numbers now. 28 is 7 times 4. 63 is 7 times 9. 56 is 8 times 7, and 35 is 5 times 7. So notice that we can cancel a 7 on the left, and on the right we can also cancel a 7. Now there's nothing else that we can cancel. So all we got to do is multiply 4 by 8, which is 32, and then 9 times 5, which is 45. And this is the answer. Notice that we didn't need a calculator for this example. So the answer is 32 divided by 45. Now what about dividing two fractions? What's 36 over 52 divided by 27 over 65? Whenever you want to divide two fractions, you want to keep in mind this expression: keep, change, flip. So what it means is you need to keep the first fraction the same. Next, change division to multiplication, and then flip the second fraction. So now this problem is like the last problem. So instead of multiplying 36 by 65, let's break down 36 into more manageable numbers. 36 is 9 times 4. 52 is 13 times 4. 65 is 13 times 5. And 27 is 9 times 3. So we could cancel a 13. We can get rid of a 4. And we can get rid of a 9. So the final answer for this problem is 5 divided by 3. So that's just a basic review of fractions. Things you just have to know if you're going to take algebra, trig, pre-cal, calculus, or any other higher level math class. So make sure you know these principles. Now, the next thing you need to understand is adding and subtracting like terms. For example, let's say if you want to simplify this expression, 5x plus 3x squared minus 7x plus 4x cubed plus 8x squared. Now, you can't add 5x and 3x squared. They're not like terms. X and x squared are completely different. You can, however, combine 5x and negative 7x, because the 5 and negative 7, they're attached to the same thing, that is x. So 5 plus negative 7, that's a negative 2. So you can combine that into negative 2x. Those are like terms. We can't add 3x squared with 4x cubed. They're not like terms. X squared and x cubed are different. We can, however, combine 3x squared and 8x squared. Those are like terms. So all you got to do is add 3 plus 8, and that will give you 11. And then the last one, you can't combine it with anything, so that's just 4x cubed. So make sure you know when you can combine certain terms and when you can't. Now, we mentioned that we cannot add 5x plus 3x squared, but can we multiply 5x times 3x squared? So you can't add unlike terms, but you can multiply them. 5 times 3 is 15. X times x squared is x cubed. When you're multiplying variables, you need to add the exponents. For example, x to the 4th times x to the 7th, that's going to be x to the 4 plus 7, which is x to the 11th. When dividing, you can subtract the exponents. So x to the 7th divided by x to the 4th is the same as x to the 7 minus 4, which is x cubed. And when you raise one exponent to another, let's say x cubed raised to the 4th power, you need to multiply the exponents. 3 times 4 is 12. So that's x to the 12th. Now, here's something that can help you to understand why that works. So let's say if you're multiplying x squared by x cubed, I like to think of it this way. X squared means that you're multiplying x times x, two x variables. X cubed means that you're multiplying x times x times x, three x variables. So in total, you're really multiplying 5 x variables, and 2 plus 3 is 5. So that's why when you're multiplying variables of the same type, you're allowed to add the exponents. When you're dividing, let's say x to the 5th divided by x cubed. X to the 5th is basically 5 x variables multiplied to each other. X cubed is 3 x variables. So you can cancel 3 on top and 3 on the bottom, which leaves 2 left over on top. So x 5 minus 3 is x to the 2nd power, which is what we have, 2 x variables left over. So when you're dividing, you need to subtract the top exponent by the one on the bottom. So for example, let's say if we have x to the 5th divided by x to the 8th. So it's going to be x to the 5 minus 8, which is x to the negative 3. Now when you have a negative exponent, to make it positive, you can take the x variable and move it to the bottom. If you do so, the negative 3 will now become positive 3. And typically, in the algebra course, you want to get rid of any negative exponents. You want to make all of them positive. Now, if you want to understand why it works this way, you could expand the expression. X to the 5th is 5x variables multiplied to each other. And x to the 8 is 8x variables multiplied to each other. So we can cancel 5 on top and 5 on the bottom. So notice that it leaves us with 3x variables on the bottom. That's why the answer is 1 over x cubed. Now, when you raise in one exponent to another power, we said we need to multiply. 2 times 3 is 6. Now let's understand why. X squared raised to the third power means that we're multiplying 3 x squareds together. Whenever you have an exponent, what it means is repeat multiplication. That's what it represents. So we're multiplying x squared 3 times. And x squared means that we're multiplying x 2 times. So in total, we're multiplying 6 x variables. That's why it's x to the 6th power. And so that's why you got to multiply 2 and 3 together. Now let's look at another example. So let's say if we want to multiply x to the 4th power 3 times. So it's x to the 4th times x to the 4th times x to the 4th. So basically, each x to the 4th represents 4 x variables multiplied to each other. So what we have is a total of 12 x variables. So it's x to the 12th. So 4 times 3 is 12. So anytime you raise one exponent to another power, you need to multiply those two exponents. So here's some examples that you could work on. Go ahead and simplify these problems. Let's say if we have 5x cubed times 7x to the 4th. And then 28x to the 5th divided by, let's say, 40x squared. And 3x to the 4th raised to the 2nd power. Let's start with the first example. 5 times 7 is 35. X cubed times x to the 4th. So we need to add the exponents. 3 plus 4 is 7. So the answer is 35x to the 7th. Now let's move on to the second example. 28 is 7 times 4. 40 is 10 times 4. Now x to the 5th, I'm going to break it down into x cubed and x squared, because 2 plus 3 is 5. So I can cancel a 4 and I can cancel x squared. So the final answer is going to be 7x cubed divided by 10. Now, in the next example, I need to multiply the exponents. 3 is the same as 3 to the 1st power. So 1 times 2 is 2. So I have 3 squared. And then 4 times 2 is 8. So this is going to be x to the 8th power. 3 squared is 3 times 3, which is 9. So the final answer is 9x to the 8th power. Now let's try some other similar examples. Try these. 30x to the 5th divided by 48x to the 9th power. And then 4x cubed y squared multiplied by 3x cubed y to the 5th. And finally, 4x to the 4th y to the 5th raised to the 3rd power. So take a minute and work on these examples. Go ahead and pause the video, and once you finish it, unpause it and check your work. So in the first example, I'm going to break down 30 into 6 times 5, and 48 is 6 times 8. X to the 9th, I'm going to write it as x to the 5th times x to the 4th, because 5 plus 4 is 9. And now I'm going to cancel. So I can cancel a 6 and x to the 5th. So the final answer is 5 over 8 x to the 4th power. Now for the next example, I need to multiply 4 by 3, which is 12. And then x cubed times x cubed, 3 plus 3 is 6. and then y squared times y to the 5th, which is y to the 7th. And so this is the answer, 12x to the 6th, y to the 7th. Now for the last example, I need to multiply every exponent by 3. So 1 times 3 is 3, 4 times 3 is 12, 5 times 3 is 15. 4 to the 3rd is 4 times 4 times 4. 4 times 4 is 16, 16 times 4 is 64. So the solution is 64x to the 12th power times y to the 15th power. Now, it's important to note that anything raised to the 0 power is always 1. So 3x y squared raised to 0 is just going to be a 1. Now, if you have a negative outside of it, then this is going to be a negative 1. Now, let's say if you're given these 3 problems. I want to make sure you understand the difference and what to do if you ever see this on a test. What is negative 3 squared when the negative is not part of a parentheses? When the negative is not inside a parentheses, the 2 only affects the 3, not the negative sign. So what this means is you have negative, and then you multiply 2 3's together, 3 times 3. 3 times 3 is 9, so your final answer is just negative 9. If you type this in exactly the way you see it in a scientific calculator, it's going to give you negative 9. Now let's look at the next example. The negative sign is now inside the parentheses, so it's affected by the 2. So there's 2 of them. We'll multiply negative 3 by negative 3, which is positive 9. Again, if you were to type this in exactly the way you see it in a calculator, it's going to tell you it's positive 9. Now the last example has 1 negative on the outside, and on the inside are multiplying 2 negative 3's together. So when you're multiplying 3 negatives, overall it's negative. Negative 3 times negative 3 is positive 9. And then negative times positive 9, overall is negative 9. Let's say if you were to see something that looks like this, 3x times 5x minus 4, and you're asked to simplify this problem, what would you do? In this case, all you can do is distribute. That is to multiply 3x to 5x and also multiply 3x by negative 4. That's the process of distribution. 3x times 5x. 3 times 5 is 15. X times x is x squared. And then 3x times negative 4 is negative 12x. So that's all you could do in this problem. Whenever you multiply in one term, which is the 3x, by 2 terms, then you're distributing. Or if you multiply in one term by 3 terms, you're distributing. A single term is a monomial. 2 terms is a binomial. 3 terms, a trinomial. If you have many terms, a polynomial. So this here is a binomial because there are 2 terms, 1, 2. Now, what if we wanted to, let's say we want to multiply a binomial, 2x plus 3, by another binomial. What should we do? In this case, we need to FOIL. Perhaps you heard of this expression. The F stands for first. You want to multiply the first 2 terms, and then you want to multiply the stuff on the outside, 2x by negative 5, and then the stuff on the inside, and then finally the last terms. But let's do it in order. So first, let's multiply 2x by 3x. So that's going to be 6x squared. And then let's multiply the terms on the outside, 2x times negative 5, which is negative 10x. And then let's multiply the 2 terms on the inside, 3 times 3x, which is positive 9x. And then finally, the last terms, 3 times negative 5, which is negative 15. Now, we need to simplify this algebraic expression. So we need to combine like terms. Negative 10x plus 9x. That's going to be negative 10 plus 9, which is like 9 minus 10, that's negative 1. Negative 1x and negative x are the same. So this is the answer. It's 6x squared minus x minus 15. What about this example? What's 3x minus 4 raised to the second power? What do you think we need to do in this problem? Well, keep in mind, whenever you see an exponent, it represents repeat multiplication. So what we really have is 3x minus 4 times itself 2 times. So once again, we need to FOIL it. 3x times 3x is 9x squared. And then 3x times negative 4, that's negative 12x. Negative 4 times 3x is also negative 12x. And finally, negative 4 times negative 4 is positive 16. Now, just like the last example, we're going to combine like terms. Negative 12x plus negative 12x, that's negative 24x. And so this is the answer. 9x squared minus 24x plus 16. Now, what about multiplying a binomial by a trinomial? Go ahead and try this problem. Now, when it gets complicated like this, I like to line things up. So let me show you. 2x times 4x squared. That's 8x cubed. So you got to add 1 plus 2, which is 3. Next, we have 2x times negative 3x. That's going to be negative 6x squared. And finally, 2x times 6 is 12x. Next, we have 5 times 4x squared, which is 20x squared. I'm going to put it below the negative 6x squared. And then 5 times negative 3x, that's negative 15x. And lastly, 5 times 6, which is 30. Now, the reason why I like to align it like this is I could easily identify the like terms. Negative 6x squared and 20x squared, those are like terms. 8x cubed, there's nothing else like it that I can combine it with, so I'm just going to bring it down. Negative 6 plus 20, that's positive 14. 12 and negative 15, that adds up to negative 3. So this is the answer. 8x cubed plus 14x squared minus 3x plus 30. Here's another example. 3x squared minus 2x plus 4 times 4x squared plus 5x minus 6. So in this example, we're multiplying a trinomial by a trinomial. So initially, before we combine like terms, we should have 9 terms because 3 times 3 is 9. In the last example, before we combine like terms, we had 6 terms because 2 times 3 is 6. So let's multiply 3x squared by 4x squared. So that's going to be 12x to the 4th. Next, let's multiply 3x squared by 5x. And so that's going to be 15x cubed. And then we're going to multiply 3x squared by negative 6, which is just negative 18x squared. Now you got to be careful that you don't make a mistake, because the longer the problem, the easier it is to make a single mistake, which can mess up the whole problem. So you need to double check your work when doing problems like this. Negative 2x times 4x squared, that's negative 8x cubed. So I'm going to line it up just to avoid mistakes. And then negative 2x times 5x, that's going to be negative 10x squared. Next, we have negative 2x times negative 6, which is positive 12x. Now let's move on to the next part. 4 times 4x squared, that's positive 16x squared. And then 4 times 5x, that's 20x. And finally, 4 times negative 6, which is negative 24. So as you can see, we have a total of 9 terms before combining like terms. 3, 6, 9. Now we can't combine 12x to the fourth with anything, so let's bring it down. 15 plus negative 8, that's positive 7. And then negative 10 plus 16, that's positive 6. And negative 18 plus 6, that's going to be negative 12. Twelve plus 20 is 32. And so this is the answer. 12x to the fourth plus 7x cubed minus 12x squared plus 32x minus 24. Now let's talk about solving basic equations. You need to master the skill, especially if you're going to go into an algebra course. Let's start with this one. X plus 8 is equal to 15. X is basically a variable in which you currently don't know what the value of. X is a number. It represents a specific number. So what number plus 8 is equal to 15? Well, it turns out that 7 plus 8 is 15. So therefore X has to be 7. Now how do we show our work? How do we show that X is equal to 7? Whenever you need to solve an equation, whenever you need to find a value of a variable, the best way to do that is to get that variable by itself on any side of the equation. So basically, if we can move the 8 from the left side to the right side, we can get the x variable by itself on the left side. And the value that's on the right is going to be equal to the value of x. And that's basically what you're doing when you're solving an equation. You want to find the value of a variable. Now the opposite of addition is subtraction. So to get rid of the 8 on the left, we need to subtract both sides by 8. 8 plus negative 8 is 0. So now what we have left over is x is equal to 15 minus 8, which is 7. And so that's how you could find the value of x. Let's look at another example. X minus 4 is equal to 12. So once again, we need to get x by itself on the left side or on the right side to find its value. So let's keep it on the left, but let's get rid of the negative 4 on the left. The opposite of subtraction is addition. So we need to add 4 to both sides. 12 plus 4 is 16. And you could check the work. 16 minus 4 is equal to 12. So x has to be 16. Now what about this example? If 3x is equal to 15, what is the value of x? So how can we separate the 3 from the x? How can we get rid of the 3 on the left side? Well, right now the 3 is multiplied to x. So if you want to get rid of it from the left side, perform the opposite operation of multiplication. The opposite of multiplication is division. So what you want to do is divide both sides by 3. 3 divided by 3 is 1. So on the left, we're going to have 1x, which is the same as x. 15 divided by 3 is 5. And that is the answer. X is equal to 5. Now, if x divided by 6 is equal to 4, what is the value of x? The opposite of division is multiplication. So in this example, we want to multiply both sides by 6. 6 divided by 6 is 1, so those two numbers will cancel. And on the right, we have 4 times 6, which is 24. And so that's the value of x. Now what about this example? 2/3 of x is equal to 8. What is the value of x? So what you can do is you can multiply by the reciprocal of the fraction. So let's multiply the left and the right sides by 3 divided by 2. On the left side, the 3's will cancel and the 2's will cancel. So all we have left over is x. 8 is the same as 8 divided by 1. And you know how to multiply fractions. You got to multiply across. So 8 times 3 is 24. And 1 times 2 is 2. And 24 divided by 2 is 12. And this is the answer. Now let's move on to more difficult examples. So sometimes you may need to solve a multi-step equation like this one. So if 3x plus 5 is equal to 11, what is the value of x? Now, you don't want to divide everything by 3. If you do, it's not going to be nice. Instead, you want to subtract both sides by 5 first. If you do it this way, it's going to be a lot easier. And with practice, you'll get the hang of it. 11 minus 5 is 6. And now what we can do is divide both sides by 3. So x is equal to 2. The best way to learn algebra is to make sure to work through most of the homework problems that can be found in your textbook. The more problems you do, the better you'll become with math. So it's based on the effort that you put in. The more effort you put in, the more you get out from it. Try this example. Let's say 2x minus 7 is equal to 3. Find the value of x. So we're not going to worry about the 2. Right now, let's get rid of the 7 on the left side. So let's add 7 to both sides. Three plus 7 is 10. And so 2x is equal to 10. Now once you get to this part, you can separate the 2 and the x by division. And 10 divided by 2 is 5, so this is the solution. X is equal to 5. And you can plug it back in to see if the answer is correct. So 2 times 5 minus 7, is that equal to 3? 2 times 5 is 10, and 10 minus 7 is 3. So the equation is balanced. Now let's move on to an example where we have variables on both sides of the equation. So let's say that 4x plus 3 is equal to 6x minus 15. Now what do you think we need to do in this example? Your goal is to get all of the x variables on one side and every number that doesn't have an x variable on the opposite side. So because 6 is larger than 4, I'm going to subtract both sides by 4. I don't want to deal with negative numbers if I don't have to. Now at the same time, we can add 15 to both sides. So all of the variables, I'm moving it to the right side. I no longer have an x variable on the left side. And all of the constants, the numbers without a variable, is all on the left side. 3 plus 15 is 18, 6x minus 4x is 2x. So once I get to this part of the equation, all I need to do is divide both sides by 2. 18 divided by 2 is 9. So as you can see, solving equations, linear equations, is not very difficult. You can learn this. You can do this. Now what would you do if you have a linear equation that contains parentheses and variables on both sides? So if you see this, don't let it concern you. You can do this. The first thing you should do is distribute. So let's multiply 3 by 2x. So this is equal to 6x. And then multiply 3 by negative 4, which is negative 12. Now on the right side, distribute the 5. 5 times 3x is 15x. And then 5 times 2, that's 10. And let's not forget the negative 3 that we have on the right side. So at this point, combine like terms if there are any. On the right side, we can combine 10 minus 3, which is 7. So now, we're at the point at the start of the last example. 15 is larger than 6, so I'm going to subtract both sides by 6x. So I will no longer have a variable on the left side. Now, I want to move all my constants to the left side because the x variable is now on the right side. So therefore, I need to get rid of the 7. So I'm going to subtract both sides by 7. So all I have on the right side is 15x minus 6x, which is 9x. On the left side, negative 12 minus 7, which is negative 19. Now all you could do at this point is divide by 9. So x is equal to a fraction, negative 19 divided by 9. Now, you may get examples where you have to solve equations that contain fractions. So consider this problem. 2/3 x plus 5 is equal to 8. What is the value of x? Now what I like to do is I like to get rid of the fraction from the beginning. There's many different ways of going about solving this equation, but this is just the method that I prefer. I'm going to multiply everything by 3, by the denominator of this fraction. So 3 times 2/3, the 3's will cancel, leaving behind simply 2x. And then I'm going to multiply 3 by 5, which is 15. And finally 3 times 8, which is 24. And so now I have an equation that is a lot easier to deal with. So next I'm going to subtract both sides by 15. And 24 minus 15, that's 9. And then divide both sides by 2. So x is equal to 9 over 2. Since the numerator is greater than the denominator, we have what is known as an improper fraction. So what you can do is you can turn it to a mixed number. 9 is basically 8 plus 1. 8 divided by 2 is 4. And 4 plus 1/2 is 4 and 1/2 as a mixed number. So x is basically equal to 4.5 as a decimal. Let's try another example. 3/4 x minus 2/3 is equal to 12. Calculate the value of x. Now this time, there are two fractions in this equation. So should we multiply both sides by 3 or by 4? If you want to get rid of both fractions, you should multiply by both numbers, 3 and 4. 3 times 4 is 12. But I'm going to leave it as 4 and 3. So if we multiply this fraction, 3/4, by 12, what will we get? Well, the 4's will cancel, and so we're left with 3 times 3, which is simply 9. So therefore, 3/4 x times 12 is going to be 9x. Now, we need to multiply 2/3 by 12. So as you can see, the 3's will cancel, and we're left with 2 times 4, which is 8. And 12 times 12 is 144. Now we no longer have any fractions. So let's finish the problem. Let's add 8 to both sides. 144 plus 8 is 152. And then we could divide both sides by 9. So x is 152 divided by 9. Now let's turn this into a mixed number. And this time I'm going to use a long division. So how many times does 9 go into 15? 9 goes into 15 one time. 9 times 1 is 9. 9 times 2 is 18, which exceeds 15. Now 15 minus 9 is 6. So now let's bring down the 2. 9 goes into 62 6 times. 9 times 7 is 63, so that's too much. 9 times 6 is 54. And 62 minus 54 is 8. So to convert this into a mixed number, 9 goes into 152 16 times. So that's going to be the number outside of the fraction. And then the denominator is going to stay 9. And then what remains, the remainder, is the numerator of the mixed fraction. So it's 16 and 8 over 9. Now other times, you may have linear equations that contain decimals. I think this is going to be easier than the last example. So let's try it. Go ahead and calculate the value of x in this problem. Now notice that every number is rounded, or it's at the 10th place. So therefore, multiply everything by 10. 0.8 times 10 is 8. 0.3 times 10 is 3. 0.5 times 10 is 5. And 1.4 times 10 is 14. And now it's a lot easier to solve it. So let's subtract 3 from both sides, and let's subtract 5x from both sides. 8x minus 5x is 3x, and 14 minus 3 is 11. So the last thing we need to do is divide by 3. So x is equal to 11 over 3. 11 over 3 is basically 9 over 3 plus 2 over 3. And 9 divided by 3 is 3. So we got 3 plus 2/3, which as a mixed number, is 3 and 2/3. Or 3.67 as a decimal. Now let's look at another example. 0.34x plus 0.12 is equal to 0.26 minus 0.15x. Go ahead and find the value of x. So in this example, notice that each number is at the hundredths place. So to turn everything into a whole number, multiply everything by 100. 0.34x times 100 is 34x. And then the next number is going to be 12, and then 26 minus 15x. So basically, you just got to move the decimal point 2 units to the right if you're multiplying a number by 100. Now let's solve, as we've been doing before. So let's add 15x to both sides, and let's subtract both sides by 12. 34 plus 15, that's 49. 26 minus 12 is 14. So now let's divide both sides by 49. So x is equal to 14 over 49, which we could simplify that fraction. 14 is 7 times 2. 49 is 7 times 7. So therefore x is equal to 2 divided by 7. And so that's the solution for this problem. What would you do if you have two fractions separated by an equal sign? So let's say x divided by 5 is equal to 8 over 9. What is the value of x? Whenever you have two fractions separated by an equal sign, you can cross multiply. 5 times 8 is 40, and x times 9 is 9x. And then we could divide by 9. So x is equal to 40 over 9. And that's all you got to do if you have two fractions separated by an equal sign. So let me give you another example. Let's say we have 3x plus 2 divided by 5 is equal to 2x minus 5 divided by 4. Calculate the value of x. So first cross multiply. So we have 4 times 3x plus 2, and that's equal to 5 times 2x minus 5. Now in this example, we need to distribute. So let's distribute 4 to 3x plus 2. 4 times 3x is 12x, and 4 times 2 is 8. 5 times 2x is 10x, and 5 times negative 5 is negative 25. And then it's like another problem that we've seen multiple times. So let's subtract both sides by 10x, and let's subtract both sides by 8. (12x minus 10x is 2x. Negative 25 minus 8 is negative 33. And then we'll just divide by 2. So x is equal to negative 33 over 2, which is negative 16.5 as a decimal. Now you need to be familiar with inequalities. That's going to be our next topic of discussion. Go ahead and graph these 4 inequalities. On a number line. So x is greater than 2. So what does that mean? How can we show that on a number line? If you look at the second example, it means that x is equal to or greater than 1. Let's put it 0 here. Let's put it 2. If you just have the greater than symbol on a number line, you need to draw an open circle. So x is greater than 2. We're going to put an open circle at 2. And because it's greater than, we're going to shade towards the right. Because all of the numbers that are larger than 2 or have a higher value than 2, they're towards the right of 2. Now for the second example, x is equal to or greater than 1. So we're going to have a closed circle to include 1. But we're still going to shade to the right because x can be greater than 1. For the third example, x is less than negative 2. So negative 2 is to the left of 0. And because it's not equal to negative 2, it doesn't include it, we need to use a open circle and shade towards the left because it's less than negative 2. Now for the last example, x is less than or equal to negative 3. So this time we're going to use a closed circle, but we're still going to shade towards the left. Now you need to be able to represent these solutions using interval notation. For the first example in the upper left, x is greater than 2, so the way you can write it is 2 to infinity. All the way to the right you have positive infinity, to the left negative infinity. So it starts from 2 and it ends at infinity. And if you have an open circle, always use parentheses. And for infinity symbols, you should always use parentheses. Now for the example in the upper right, this time 1 is included, so we need to use a bracket. So it's shaded starting from 1 and then towards infinity. So it's from 1 to infinity. So use brackets if 1 is included. Now for the third example on the lower left, it's shaded starting from negative infinity to negative 2. So the way you look at it is from left to right, and that's the way you write it, from left to right. So it's going to be negative infinity to negative 2. And since we have an open circle, we're going to use parentheses as opposed to brackets. Now for the last example, it starts from negative infinity and it stops at negative 3. So it includes negative 3, so we're going to use brackets there. Now go ahead and solve these two equations. 5 plus 3x is greater than, let's say, 11. Actually, let's make it 14. And also solve this one. 2 minus 5x is less than or equal to, let's say, negative 8. Now I'm going to start with the example on the left. So whenever you're solving an inequality, you can treat it as if it's an equation. View this as if it was an equal sign. So you're going to have 3x is greater than 14 minus 5, which is 9, and then divide by 3. So x is greater than 3. Now once you get this answer, represent it in two ways, using a number line and using interval notation. So because x is greater than 3, we're going to shade towards the right. And it doesn't equal 3, so we're going to use an open circle. So an interval notation is from 3 to infinity. Now for the example on the right, we need to subtract 2 from both sides. So negative 5x is less than or equal to negative 10. Now what we need to do is divide both sides by negative 5. Now here's where you got to be careful. Whenever you multiply or divide by a negative number, you need to switch the sign of the inequality. So it's going to change from less than or equal to greater than or equal to. Negative 10 divided by negative 5 is positive 2. So this is our answer, and now let's plot it on a number line. So this time we're going to use a closed circle, and we're going to shade towards the right because it can be greater than 2. So an interval notation is from 2 to infinity using brackets, since 2 is included. So that's it for this video. If you want to find more videos on algebra, you can check out my Udemy course, or you could check out my channel for videos in my algebra playlist. So thanks again for watching. Now I want to show you one of my algebra courses that might be useful to you if you ever need it. So go to udemy.com. Now in the search box, just type in algebra and it should come up. So it's the one with the image with the black background. So if you select that option, and if you decide to go to course content, you can see what's in this particular course. So the first section, basic arithmetic, for those of you who want to focus on addition, subtraction, multiplication, and division. And it has a video quiz at the end. It's a multiple choice video quiz. You can pause it, work on the problems, and see the solutions. It covers long division, multiplying two large numbers, and things like that. The next tutorial is on fractions. Adding, subtracting fractions, multiplying, dividing fractions, converting fractions into decimals, and so forth. So you can also take a look at that. Next, solving linear equations, which we covered, and just more examples if you need more help with that. The next topic, order of operations, which is also useful. Graphing linear equations, you need to know how to calculate the slope. You need to be familiar with the slope-intercept form, standard form, and just how to tell if lines are parallel, perpendicular, and so forth. And there's a quiz that goes with that as well. The next topic is on inequalities and absolute value expressions, which are also seen in a typical algebra course. And then we have polynomials, and that's a long section. And then factoring, that's another topic you need to master. And then system of equations. You can solve it by elimination, substitution. There's also word problems as well. Sometimes you got to solve equations with three variables, x, y, and z. So that could be helpful. Next, quadratic equations, how to use the quadratic formula, how to graph them, how to convert between standard and vertex form. And then you have rational expressions and radical expressions, solving radical equations, simplifying it, things like that. And every section has a quiz, so you can always review what you've learned if you have a test the next day. So here we have complex imaginary numbers. You need to know how to simplify those. Exponential, functions, logs. I have a lot of videos on logs. And then this is just functions in general. Vertical line tests, horizontal line tests, how to tell if a function is even or odd. And then conic sections, graphing circles, hyperbolas, ellipses, parabolas, and things like that. There's 2 video quizzes because it's actually a long section. And finally, arithmetic and geometric sequences and series. So that's my algebra course if you want to take a look at it, and let me know what you think.